Reciprocating compressor. Introduction. Compressors are work-absorbing devices which are used for increasing pressure of fluid at the expense or work done on fluid. The device/machine used for compressing air are called air compressors. Compressors are invariably used for all applications requiring high-pressure air. Some of popular applications of compressor are, for driving pneumatic tools and air-operated equipments, spray painting, compressed air engine, supercharging surface cleaning, refrigeration and air conditioning, chemical industry etc. Compressors are supplied with low-pressure air, or any fluid, at inlet which comes out as high-pressure air, or any fluid, at outlet. Work required for increasing pressure of air is available from the prime mover driving the compressor. Generally, electric motor, internal combustion engine or steam engine, turbine etc. are used as prime movers. Compressors are similar to fans and blowers but differ in terms of pressure ratios. Fan is said to have pressure ratio up to 1.1 and blowers have pressure ratio between 1.1 to 4 while compressors have pressure ratios more than 4. Classification of compressors. Types of compressors. Compressors can be classified in the following different ways. Compressors can be classified in the following different ways. Based on principle of operation. Based on the principle of operation, compressors can be classified as positive displacement compressor, non-positive displacement compressors. In positive displacement compressors, the compression is realized by displacement of solid boundary and preventing fluid by solid boundary from flowing back in the direction of pressure gradient. Due to solid wall displacement, these are capable of providing quite large pressure ratios. Positive displacement compressors can be further classified based on the type of mechanism used for compression. These can be reciprocating type positive displacement compressors, rotary type positive displacement compressors. Reciprocating compressors generally employ piston-cylinder arrangement where displacement of piston in cylinder causes rise in pressure. Reciprocating compressors are capable of giving large pressure ratios but the mass handling capacity is limited or small. Reciprocating compressors may also be single-acting compressor or double-acting compressor. Single-acting compressor has 1 delivery stroke per revolution while in double-acting there are 2 delivery strokes per revolution of crankshaft. Rotary compressors employing positive displacement have a rotary part whose boundary causes positive displacement of fluid and thereby compression. Rotary compressors of this type are available in the names as given below. Roots blower. Vane-type compressors. Rotary compressors of above type are capable of running at higher speed and can handle large mass flow rate than reciprocating compressors of positive displacement type. Non-positive displacement compressors, also called as steady flow compressors, use dynamic action of solid boundary for realizing pressure rise. Here fluid is not contained in definite volume and subsequent volume reduction does not occur as in case of positive displacement compressors. Non-positive displacement compressor may be of axial flow type or centrifugal type depending upon type of flow in compressor. B. Based on number of stages, compressors may also be classified on the basis of number of stages. Generally, the number of stages depend upon the maximum delivery pressure. Compressors can be single-stage or multi-stage. Normally maximum compression ratio of 5 is realized in single-stage compressors. For compression ratio more than 5 the multi-stage compressors are used. Type values of maximum delivery pressures generally available from different type of compressor are I. Single-stage compressor, for delivery pressure up to 5 bar. 2. Two-stage compressor, for delivery pressure between 5 to 35 bar. 3. Three-stage compressor, for delivery pressure between 35 to 85 bar. 4. Four-stage compressor, for delivery pressure more than 85 bar. C. Based on capacity of compressors, Compressors can also be classified depending upon the capacity of compressor or air delivered per unit time. Typical values of capacity for different compressors are given as I. Low-capacity compressors, having air delivery capacity of 0.15 cubic meters per second or less. 2. Medium-capacity compressors, having air delivery capacity between 0.15 to 5 cubic meters per second. 3. High-capacity compressors, having air delivery capacity more than 5 cubic meters per second. D. Based on highest pressure developed, depending upon the maximum pressure available from compressor, they can be classified as low pressure, medium pressure, high pressure and super high pressure compressors. Typical values of maximum pressure developed for different compressors are as under. I. Low pressure compressor, having maximum pressure up to 1 bar. 2. Medium pressure compressor, having maximum pressure from 1 bar to 8 bar. 3. High pressure compressor, having maximum pressure from 8 to 10 bar. 4. Super high pressure compressor, having maximum pressure more than 10 bar. Reciprocating compressors. Reciprocating compressor has piston-cylinder arrangement. Reciprocating compressor. Reciprocating compressor has piston, cylinder, inlet valve, exit valve, connecting rod, crank, piston pin, crank pin and crankshaft. Inlet valve and exit valves may be of spring-loaded type which get opened and closed due to pressure differential across them. Let us consider piston to be at top dead center, TDC, and move towards bottom dead center, BDC. Due to this piston movement from TDC to BDC, suction pressure is created causing opening of inlet valve. With this opening of inlet valve and suction pressure, the atmospheric air enters the cylinder. Air gets into cylinder during this stroke and is subsequently compressed in next stroke with both inlet valve and exit valve closed. Both inlet valve and exit valves are of plate type and spring-loaded so as to operate automatically as and when sufficient pressure difference is available to cause deflection in spring of valve plates to open them. After a piston reaching BDC, it reverses its motion and compresses the air inducted in previous stroke. Compression is continued till the pressure of air inside becomes sufficient to cause deflection in exit valve. At the moment when exit valve plate gets lifted, the exhaust of compressed air takes place. This piston again reaches TDC, from where downward piston movement is again accompanied by suction. This is how reciprocating compressor keeps on working as flow device. In order to counter for the heating of piston-cylinder arrangement during compression, the provision of cooling the cylinder is there in the form of cooling jackets in the body. Reciprocating compressor described above has suction, compression and discharge as 3 prominent processes getting completed in 2 strokes of piston or 1 revolution of crankshaft. Thermodynamic analysis. Compression of air in compressor may be carried out following number of thermodynamic processes such as isothermal compression, polytropic compressor or adiabatic compressor. Theoretical cycle is shown neglecting clearance volume, but in actual cycle clearance volume cannot be negligible. Clearance volume is necessary in order to prevent collision of piston with cylinder head, accommodating valve mechanism etc. Compression process is shown by process 1-2, 1-21, 1-211 and 1-2111 following isothermal, polytropic and adiabatic processes. On PV diagram, process 4-1 shows the suction process followed by compression during 1-2 and discharge through compressor is shown by process 2-3. Air enters compressor at pressure P1 and is compressed up to P2. Compression work requirement can be estimated from the area below the each compression process. Area on PV diagram shows that work requirement shall be minimum with isothermal process 1-2. Work requirement is maximum with process 1-2E, adiabatic process. As a designer, one shall be interested in a compressor having minimum compression work requirement. Therefore, ideally compression should occur isothermally for minimum work input. In practice it is not possible to have isothermal compression because constancy of temperature during compression cannot be realized. Generally, compressors run at substantially high speed while isothermal compression requires compressor to run at very slow speeds so that heat evolved during compression is dissipated out and temperature remains constant. Actually, due to high-speed running of compressor, the compression process may be assumed to be near adiabatic or polytropic process following law of compression as PVN equals C with of N varying between 1.25 to 1.35 for air. As a designer, one shall be interested in a compressor having minimum compression work requirement. Therefore, ideally compression should occur isothermally for minimum work input. In practice it is not possible to have isothermal compression because constancy of temperature during compression cannot be realized. Generally, compressors run at substantially high speed while isothermal compression requires compressor to run at very slow speeds so that heat evolved during compression is dissipated out and temperature remains constant. Actually, due to high-speed running of compressor, the compression process may be assumed to be near adiabatic or polytropic process following law of compression as PVN equals C with of N varying between 1.25 to 1.35 for air. Compression process following three processes is also shown on TS diagram and figure. It is thus obvious that actual compression process should be compared with isothermal compression process. A mathematical parameter called isothermal efficiency is defined for quantifying the degree of deviation of actual compression process from ideal compression process. Isothermal efficiency is defined by the ratio is isothermal work and actual indicated work in reciprocating compressor. Practically, compression process is attempted to be close to isothermal process by air/water cooling, spraying cold water during compression process. In case of multi-stage compression process, the compression in different stages is accompanied by intercooling in between the stages. P2V2. Mathematically, for the compression work following polytropic process, PVN equals C. Assuming negligible clearance volume, the cycle work done, WC equals area on PV diagram. WC equals 1 equals